So I want to spend a little bit of time also talking about Nomad 0.9 and highlight a few of the new features that are coming as well. So one of the big focuses for us has been really looking at how do we make the scheduler smarter, right? And I think what we've seen over time as we get sort of increasingly sophisticated use cases like circles is people want more control over how Nomad places and schedules and manages their application. And so a common ask has been affinities and spreading. Right? And the idea behind affinities is how do you hint to the scheduler that you would prefer to be placed in a certain location, right? So Nomad has always supported the notion of what we call a constraint. A constraint is something that must be satisfied, right? So if you tell Nomad, my job must run on Linux or my job must run on Windows, there's no way for Nomad to sort of fib that, right? If your app is designed to run on Linux, it's not going to work on Windows. So the constraint must be satisfied. Versus an affinity is more of like it's a thing I would like, right? And a perfect example of this might be maybe you're able to use certain kernel features that you know makes your application faster on certain platforms. Or there's certain hardware instructions that your app can potentially leverage that makes it faster, right, on certain classes of hardware. So in these cases, it's not make or break if you're not running on that environment, but you'd like to provide the hint such that if that hardware is available or if that OS is available, then all the better your app can leverage it. So what that looks like now with the latest version of Nomad is you can add this affinity block. And what you're really hinting to the system is, here's a set of things I would prefer to optimize for, right? And you can really optimize across anything you want, right? It could be operating system, it could be version of application installed, maybe a Docker version, could be hardware properties. Really anything that Nomad knows about, you can use as something to optimize your job against. And so in this simple example, we were just optimizing against the kernel version, right? So we're pinning against the kernel version and saying we would prefer to be later than 3.19, right? And maybe there's some new features that we're leveraging in that. And so we're going to say, great, if that's available, put us there. If not, find some other Linux machine, still place us there, right? And so it makes it super easy for us to sort of customize where we're placing the app. And you have this weight property that lets you sort of express a preference of how much does this matter to you, right? If it's super, super important, then great, we'll try harder and maybe move workloads around to make that possible. If it's not a huge deal, you can provide a lower weight to it. At the same time, there's sort of the reverse of that, which is what if we really don't prefer a certain class of hardware, right? And so this is an anti-affinity. And there might be reasons for that. Maybe we know that our app doesn't do well on spinning disk, right? And we need an SSD, so we have sort of a strong anti-affinity to spinning disks. Or we know it doesn't perform well on a particular version, things like that. So we can do almost the same thing as affinity, but really are just assigning now a negative weight. And just saying we negatively prefer the same attribute as we would have for an affinity. The other one that's super interesting is spreading. Right? And so typically what Nomad will do, and I think this is something Rob highlighted, is try and bin-pack applications as much as possible. Right? So we're trying to fill up the existing hardware in the fleet and maximize our utilization. So we want to get all of our existing hardware to be fully utilized before we start utilizing new hardware. Right? And so this lets us sort of scale down and get rid of machines that are effectively idle by packing in things onto other hardware. And so this is Nomad's default behavior, is this bin pack, right? But there's good reasons why we might not want to do that. We might want to specifically spread out our applications on purpose, right? Typically, it's for things like availability or modeling or sort of fault tolerance zones, right? So a perfect example of this is, suppose we have two data centers, right? Data center East and data center, East 1 and East 2. We might not want all of our applications to end up being bin-packed in East 1 so that we have East 1 at 100% utilization and East 2 at 0% utilization, right? Instead, we'd like to specify to Nomad, we want a spread between these. So you can pick any property, much like with Affinity, and say, on this axis, on this dimension, I'd like to spread workload. Right? So we might like to spread our workload between 50% East 1, 50% East 2, and then within those regions, Nomad will still bin pack. So we'll still make sure we're packing data center 1 and packing data center 2, but spreading across that dimension. So this lets you get into either modeling things like availability zones and data centers for fault tolerance, but also if you're worried about bugs in kernel versions, right? You might have a spread across different versions of the kernel that you're running against. So if there's a bug in one runtime, it doesn't affect all instances of your application. So you can pick different sort of axes to spread your workload across. Another interesting sort of property of Nomad scheduling is that it's priority based. So any job you submit to the system, you tell us what's the priority, right? 0 to 100. And Nomad tries to give preferential access to resources. So higher priority jobs get scheduled first. If there's contention on resources, they sort of win out. So we try and use this priority as sort of the deal breaker so that you can give us sort of your business logic of hey, my front-end facing user traffic is more important to me than my sort of nightly batch processing is, right? So you can kind of encode that, and the scheduler will respect it. Now, the challenge is what happens when the cluster is totally busy, right? You have a cluster that's 100% full, and now new work shows up, right? What Nomad does is basically park it in a queue, right? There's no work, there's no capacity available, so great, put it in a queue, wait until room frees up, and then when there's room, we'll go schedule that application for you. So this is nice from the perspective of we can treat Nomad as a job queuing server. We don't have to build sort of reconcile logic of if it's busy, come back and try again. Nomad will deal with it. But you can deal with it, you can end up with this sort of priority inversion, right? So if I have a cluster that's totally full with low priority work and a high priority job shows up, that high priority job is now sitting in a queue waiting for low priority work to finish, right? And so this is a classic problem known as priority inversion. You can't have high priority work wait on low priority work. And so the way we're solving this is by adding preemption in 0.9. So when the scheduler detects that it's in this configuration, right, it's totally full, there's no additional capacity, but now we have high priority work that's arrived, how do we evict low priority work to make space for the high priority work, right? So really the low priority work can sit in the queue, the high priority work is the one that should go execute right away. Right? So we're adding this across the board. The system scheduler in Nomad, which is responsible for running all of the sort of agents that run everywhere, monitoring, logging, sort of security agents, things like that. The system scheduler is responsible for that, is gaining preemption in 0.9 in the open source. And then the service and batch schedulers are gaining this ability in enterprise subsequently. Another common feedback we've gotten with Nomad is how do we make this thing easier to integrate with my ecosystem? Nomad is already relatively unopinionated about how things should work, but how do we make it even more flexible to bringing in different ways of thinking about running jobs or different devices, things like that? So with 0.9, there's been a big investment in the pluggability of the system. And the first two things that are showing up are task drivers. So task drivers are how Nomad actually executes. So Docker and LXC and QEMU are examples of task drivers. So when you provide Nomad a Docker job, the Docker task driver is the one responsible for executing it. But what if we want to customize that, right? We want to build our own task driver specific to maybe Node.js, or we want to take the Docker one and modify the way it actually behaves to fit into our environment. So now what we can do is support that being a pluggable thing. It no longer has to be compiled into Nomad. You can have a custom driver and do sort of specialized logic within it. The other kind of common challenge is how do we manage sort of not stock devices? So FPGAs, TPUs, GPUs, other specialized hardware. How do we make Nomad aware of it and so that it can manage it and schedule against it? And so historically, it's been you have to make the core product aware. Where now we're adding a whole sort of driver interface so that you can plug in sort of additional devices, and Nomad will become aware to be able to do scheduling and management and resource isolation of that hardware. Right? And so all of this is really part of laying the foundation to have even more plugins in future releases. So really looking at how do we make the system super pluggable and super extensible. One plugin that we're super excited about is the NVIDIA GPU one. Right? So a lot of our sort of use cases, as I mentioned, are around this sort of large-scale batch processing. And increasingly, we have users and customers who want to leverage graphic cards to accelerate workloads like machine learning. And so if you have a super parallel scheduler attached to super parallel hardware like GPUs, this is sort of a perfect match for building things like complex ML pipelines. Right? And so this is something we're super excited about that's landing with the next version of Nomad. So as we talk about 0.9, it's really kind of this focus on how do we make the system smarter and richer as we see these different use cases emerging. And so there's a whole host of new features. The 0.9 preview will be available shortly, maybe as early as next week. And the generally available release should be as early as early November. So keep eyes peeled. And now I'd like to introduce Mitchell Hashimoto, founder and CTO of HashiCorp, to the stage to tell us a little bit more. Thank you so much.